So in this booklet, we will look at the nuclear atom topic, MCQs, and their explanations. Number one says N nitrogen 715 contains 7 protons and 8 neutrons. Remember, the number at the top is the sum of protons and the neutrons. The number at the bottom is just the number of protons or electrons. So which ones are isotopes? The one that has the same number of protons and different number of neutrons, which is P2 protons and the black ones, and 2 protons, the black ones. P and R are the isotopes. Radioactive decays, what is X? It is an electron, also a beta particle, called beta particle. So a nucleus with this much nucleons and protons, it emits alpha particle. So in alpha particles, the neutrons decrease. So the number of neutrons here are 146. When alpha is emitted, protons become 92 and the neutrons become 144. C. Geiger-Marsden experiment, alpha particles, thin gold foil, and that what is deducted is that the nuclei are much smaller than the atoms, because most of the alpha particles passed undeflected. Number 6, so we have carbon and nitrogen. The nitrogen has 1 proton more than the carbon because of the number 6 and number 7 here at the bottom. Smallest mass is electron. It is the hydrogen that fuses together and gives a lot of energy and becomes helium. Number 9, krypton. The nucleons are 84, the number at the top. How you compare a chlorine 37 with an argon 37? Well, although the mass number of both is 37, still the chlorine has 17 electrons and 17 electrons, 17 protons, 18 neutrons, whereas the argon has 18 electrons, 18 protons, and 17 neutrons. So the both the number of electrons are different and number of neutrons are different. Number 11, same number of neutrons. Well, atomic number is 6, so it has 6 electrons, 6 protons, and 6 neutrons. Here, nitrogen atomic number is 7, so it should have 7 electrons, 7 protons, and 13 minus 7, 6 neutrons. Never forget that the number at the top subtract the number at the bottom subtracted from the number at the top gives you the number of neutrons. Geiger-Marsden experiment. Majority of alpha particles passed undeflected because the nucleus is very small. Here the isotopes are atoms, same number of protons but different neutrons, so we only consider P and Q as the isotopes. P15 emits beta particle, so in beta particles, the 1 neutron changes into 1 proton. In beta emission, 1 neutron changes into 1 proton. So emission of beta means atomic number goes +1 and no change in mass number. So 15 changes into 16 and 32 remains same, and D is the correct choice. Protons is the bottom number, 88. Helium 2,4 means it has 2 electrons and 2 protons, both from the bottom number, and top minus bottom gives you number of neutrons, 2. What is X? It is an electron, and what is Y? It is nucleus. Alpha particle emission gives you 90 minus 2 and 223 minus 4, and that is this. Nucleus contains 88 protons. Number 20. First, it emits alpha particle and then beta particle. So, U92-238 emitting alpha particles minus 2 minus 4 gives you 90-234. Emission of beta particle plus 1 gives you 91-234, 91-234. Two isotopes of chlorine. Both should have same number of protons. Why others are wrong? Not same, not same, same, but look at the number of neutrons. This is not neutron. These are the nucleons. C614 has 8 neutrons. Top minus bottom gives you neutrons, and proton is the bottom number 6. Radium and radon due to something alpha particle, which so radium in one radioactive decay, radium gives rise to radon. So ideally, it should have been given what is the number of nucleons and protons, etc. But it's not given. So just remember this very specific question, and the mechanism is here. Radium is 88-26, and radon is 86-22, and that means it is emitting alpha part. Let's see why other choices are wrong. Well, we can't predict radium will become beta particle or both or no particles. It's a strange question, but just remember this one. Proton is the same. It's another name for atomic number, and nuclear number is another name for mass number. What are isotopes? Isotopes are the nuclei with the same proton number and different nucleon number. Nitrogen is a nuclide. N715 has 7 electrons. Number 26. 92 is the number of proton and electrons. So select C and D and subtract 92 from 235 gives you 143. So these are the number of neutrons. The strontium nucleus contains 38 protons and 50 neutrons. Cobalt 2759, again same mechanism, 2732. 59 minus 27 gives you 32. Largest number of alpha particles passed undeflected straight, A. Notation is 2348. That means proton number is 23. And a different isotope should have different mass numbers. So 50 is the different mass number, 23 is the same proton or atomic number. That's why this A is an isotope of this nuclide. 31, it should have an isotope of neutral atom should have same electrons and protons. Number 32, Geiger-Marsden experiment. So let's reject A, B, and C. Positive charge is spread throughout the atom? No, that's not true. Otherwise, electrons were not going, alpha particles were not going past. They will all be absorbed in the atom. Sorry, they all would have been reflected back. Electrons are arranged in orbits. How can you say that? In Geiger-Marsden, nothing was done about electrons. Electrons are negatively charged. It is true, but in Geiger-Marsden experiment, nothing was done to verify this. So the only choice is there is a dense nucleus in the atom. And why this was the choice? Because the alpha particles came back at almost 180 degrees. So, number 33, sodium, 11 protons, 12 neutrons, 11 plus 12, 23 at the top, 11 at the bottom. C is the correct choice. So here we have a uranium emits alpha particles to become thorium, and then beta particle to become protactinium. So alpha particle means 92 goes 90, 238 goes to 34. Now, beta particle means this 90 will go 91 and 234 remains the same. So the proton number will be 91. Very interesting question. Just remember the two facts. What happens when an alpha particle is emitted and what happens when a beta particle is emitted? Write down the atomic and mass numbers, decrease them accordingly, and it shouldn't take you more than 30 seconds if you have practiced this. 35, detail about Geiger-Marsden and what it suggests. Atoms have positive charges concentrated in a small volume. Nucleus is represented this, it emits one alpha and then one beta. So one alpha means, 90, it should have been 91 here. So alpha particle means 91 goes to 89 and beta 230 should go to 226. Okay, so this one is a mistake here. Write down 91 and 989 here. Now we are emitting beta particles, so 89 will become 90. So this one will become 90. So 90 and 226. So this is the correct choice. Mistakes do happen. We are all humans. So we have top minus bottom gives you 148. Remember this. Isotopes are two or more nuclei that have same number of protons and different number of neutrons. 90 protons, 144 neutrons, emitting two beta particles, then an alpha particle. The mechanism, you know, when you emit two, your 90 should become 92. 144 should become 142 because when you emit a beta particle, one neutron changes into one proton. So the proton number increases 1, neutron decreases 1. The total mass number remains the same. So this is why it is 90 and then 40. Deuterium and tritium, two isotopes. They have same protons, as you can see at the bottom, and they have different neutrons. 2 minus 1, 1 neutron, 3 minus 1, 2 neutrons. 41, presence of nucleus. What were scattered? Alpha particles. Nitrogen has 7 protons and 7 neutrons. P, Q, R have same proton number, so They are shown here. So we can see that the P and Q have same proton numbers. So they are the isotopes. Thank you.